Okay, so let's start. And can you hear me? Can you hear me?
Yeah.
Okay. Okay, sure. So today we are going to go over learn the last sorting algorithm, namely counting sort. So far we learned three. We learned three sorting algorithms: insertion, merge, and quicksort. And we say that among them, quicksort is the most important one because in practice it is the most efficient one. So what kind of design philosophy does quicksort use?
Is it the same as others, the divide, conquer?
Yes. It uses divide and conquer, but we say that it uses divide and conquer in a different way compared with merge sort, because in quicksort we get most of the work done in the divide step. So in each divide, in each step of the divide, we will take the last. We will take the last one, the last value as the pivot, and then we will divide the array into three parts, where the left part only includes values that are smaller than or equal to the pivot, and then the middle part just includes the pivot, and then the right includes all the values that are larger than the pivot. So we will keep dividing the left and the right array, and so until each of them only has until every subarray only includes one element. So in that way, we form. In that way, we can get a sequence of subarrays with this relationship, and because each of them only includes one element, so basically we got all the numbers in the array sorted. So that is the procedure of quicksort. And so today we're going to learn the last one, whose name is counting sort. But before learning the counting sort, tell me, in the worst case, but let's go over the complexity of them. So what is the complexity of insertion sort?
O to the power O(n) to the power of 2.
1 square. So what about merge?
O(n) log n.
Yes, O(n) log n. And then here we learned quicksort, and so its worst case complexity is also n squared, but we say that in practice, it's among these three, it's the most efficient one. Okay, so here, if I ask you, so say, okay, if I tell you that we can have an algorithm, a sorting algorithm with better say complexity than all of them, so what kind of sorting, what of complexity can you think about that is better than this?
Like the best one out of the three, you asking?
No. So now today we're going to learn the counting sort algorithm whose complexity is better than all of them. So in your mind, what kind of complexity is better than all of this?
O(n) cubed.
O(n) cubed? So actually O(n) cubed is worse than all of them because it grows much faster compared with n square and log n. So it means that giving the the array of the same length is going to take more time.
Would it be
So
like
here
something
we
like
can O(n), yes, O(n) square, O(n) log n. So here we got this relationship. N cubic is larger than n square, and n square is larger than O(n) log n, and then O(n) log n is larger than O(n). Okay, so here, but keep in mind that we want this number, we want the complexity to be as low as possible. So if there is an algorithm whose complexity is O(n), we can say that is better than all of them. Okay, and actually the best sorting complexity that we can hope for is just the ON. So the reason is that given an array of n elements, to sort them, at least we need to go over every element in the array to check their values, right? Just to check these n values, the complexity is already ON. So that's why I say, okay, that the best sorting complexity that we can hope for is ON. But there cannot be anything give you a better, there cannot be an algorithm give you a better complexity than ON. Make sense?
Yeah, that makes sense.
Okay, sure. Okay, so then today we're going to learn an algorithm that gives us the ON complexity. But there is a huge limitation on the algorithm, because if there is no limitation on this algorithm, then as you can see that we're going to use this one in real life most widely, because it's the most efficient one. But contrary to that, we basically use quicksort most frequently in the real life. So the reason is that counting sort comes with a big limitation. So here, in order for us to apply counting sort on an array, so this array must satisfy one condition. The limitation is that okay, so the array must be integers, must only include integers from 0 to k. So k is the maximum value of the array. So basically, we can only apply counting sort on an integer array whose values are whose minimum value is 0, okay, or larger than 0. So this is the one condition. And so if we get an array which satisfies this condition, then the sorting complexity, the complexity given by counting sort is this, ON plus k. K is the maximum value in the array. Okay, k is the maximum value in the array. And if k is less than n, so we can just ignore k, and we see that the dominant part from the complexity comes from n. If k is less than n, we can say that the complexity of so the counting sort is basically ON. Make sense?
What's the value of k? Oh.
K is the maximum value in the array.
Oh, okay.
Yes. So here you can see that the values in the array must be integers from 0 to k. So k is the maximum value. So which means that if we're giving an integer array whose values are from 0 to k, and k is less than the length of the array, so if we apply counting sort over it, so if we apply counting sort over the array, we basically can get ON complexity. Make sense?
Yep, makes sense.
Okay, so actually here you can see that the limitation for us to use say counting sort is that the array must be integers whose minimum value is 0. But in practice, in real life, we rarely have this kind of arrays. So for example, if we want to say sort an array of numbers that corresponds to for example, the stock price, they're not integers, they're just float numbers, so we cannot apply it. And this is the limitation of it. But even though there is a limitation on this array, this algorithm, the counting sort algorithm, its design is really beautiful. So let's go. So that's why I still want to discuss it. I want to share it with you. So here, let's look at the pseudocode of counting sort. So here we find that counting sort comes with 3 parameters, which are a, b, k. What does a denote? What does a mean?
The input array?
Yes, a is the input array. What about b?
Starting array? Starting like
Can I say it again?
Starting point,
Starting point? No,
like 0.
no. So previously, okay, previously when we learn merge sort or like quick sort or insertion sort, we basically sort those algorithms in place. Okay, the in-place sorting algorithm means this. Okay, if we get an array A, so with a sequence of numbers, basically we're going to do some value exchanges in the array, so that okay, so we are going to finally A is going to be sorted. The array A is going to be sorted because we are basically switching numbers in. Okay, we're just switching numbers within this array, but here. Counting sort is a out of place sorting algorithm. So meaning that given our array A, we're going to leave A unchanged. Instead, we're going to copy and paste the values from A to another array called B of the similar size as A. We just copy the values from A to B, and so that after that, A is not sorted, and instead B is sorted. So we basically sort those numbers out of the original array. So that's why we call it out of place sorting. So so here counting sort is an out of place sorting algorithm. And so guess what is B?
Empty array.
Yes, the array, another array of the same size as A. Okay, so we basically are going to copy the values from the array, input the array A, and copy those values from A to B in a very careful way, so that at the end of the algorithm, A is left unchanged, whereas B is sorted. Is that clear?
Yes, but I do wonder, like, wouldn't it be possible to just create a new array in the counting sort function itself?
Yes, it's possible.
Okay.
Yeah. So actually, in the pseudocode that I give you, so the counting sort algorithm only takes 2 parameters, which are A and K. There's no B. So instead, you need to create the array B inside the counting sort, and then return B.
Okay, understood.
Okay. Any other question? Okay. So and here, so guess what does K denote?
The end, like the size of the array?
No, not the size of the array.
The last part?
No, because if we just want to get the size of the array, we can just go to a.length, use a.length, right? So we'll be able to get it, but no. So if K means the length of the array, we don't need to pass it. We can pretty much get this value from the inside the algorithm, just from A, right?
K is the last element in the array?
No, it's not the last one.
Is it just like an index?
No. Okay, remember what is the condition for limitation for us to apply counting sort? The array must be integers, must only include integers from 0 to K. So whereas K is the maximum value in the array, right? So here, K is just the maximum value of maximum value of array A. Make sense?
Yeah.
Okay. So in other words, before you call this function, you should already know what is the maximum value inside the array. Okay. So okay. So let's then let's look at the pseudocode. So we got counting sort, ABK, and so first we create a new array named C, and then we have a for loop, and then we have another for loop, another one, and another for loop. Okay, so basically we are able to finish this algorithm, this sorting algorithm with four loops, but it's really hard to understand these for loops. So I'm going to explain it with an example over here. Okay, so this is the pseudocode, and I'm going to use an example to explain 2530 to get an array A. 3023. Okay, so this is the input array that we got, array A that we got, and so the index of the array starts from 0. Okay, so and then we just have an array B of the same size as array A, and initially we store nothing in array B. We just created the space, which also has eight places. Okay, so here if we want to apply the counting sort of over the array A over this array A, what kind of value should we set for K?
5.
Yes. So remember, K is the maximum value. So here in this array, the maximum value is basically 5. So that's why we got K as 5. Okay. So and next, so we were able to execute the first line. Let's see 0 dot K be a new array. So what is the length of this array?
5.
5.
3?
3.
Or is it undefined or something?
Undefined. So basically, the index of the array C is going to start from 0 and ends at K, which is 5. So how long is the array?
6.
Yes. Okay, so here it's not 5, instead it's 6 because the index starts from 0. If the index starts from 1, then it will be 5. But here this is an exception, and so the index starts from 0. Okay. So this is the first time that our textbook uses the index 0 for an array, and it will be clear in a couple of moments, in a couple of minutes, why it uses the 0 as the starting index. Okay, so here we basically create an array C whose size is 6. And over here, let's say its initial index is starting index is 0 instead of 1. And so next we have for I starting from 0 to k, we have say I equal to 0. Okay, so so remember that the maximum value of k is 5. So I is going to start from 0, and we're going to increase from 0 to 5, and then assign 0 to say I. So if I ask you to use one sentence to summarize this for loop, what are you going to? So basically, what do we do in this for loop?
Are we assigning like every value of I to 0? Like every index?
Yes, we're going to fill in the array C with zeros, right? Okay, so
Yeah.
let's say initially we have I. So initially we have I as 0. So this sentence is going to be C0 equal to 0. So we are going to assign 0 to C0. So this becomes 0. And then in the next one, we are going to increase I by 1. So this becomes C1 equal to 0, right? So then we're going to assign 0 to C1. And in the next one, we're going to increase I by 1. So I becomes 2. So we're going to assign 0 to C2. And we keep doing that until I reaches k, which is 5. So what we do in the first for loop is that we assign few zeros in C, right?
Yeah.
Okay, so then let's look at the next for loop for j starting from 1 to the length of the array. So the length of the array A is going to be 8. Okay, so the length of so I starting from 1 to 8, we're going to do this. Say Aj equal to say Aj plus 1. Okay, so think about it. I would ask everyone to think about what we do in this for loop, and just use one sentence like this to summarize it. To summarize what we do in this for loop, in the second for loop.
Are we copying over the values of A to C?
Actually, it is not possible because the size of these two arrays are pretty different, right?
Are we adjusting the size of the array?
No, no, we cannot. So once an array is created, we cannot adjust its size unless we just abandon it and create a new one. Okay, actually, this is pretty hard. This question is pretty hard, and to answer that question, I'm going to go over a couple of steps, and I want you to keep thinking about that question, how to summarize this, what do we do in this for loop, okay? So first, let's say here, we are using j as the index of the array A, right? Over here, you can see that we're using j as the index of array A, whereas where j starts from 1 to the maximum length to the length of the array A. So initially we have j over here, j as 1, and so when j is 1, so we need to make it simple. We are going to translate this we're going to translate this statement into a simpler way. So let's say we are going to do this. What is AJ?
2.
2. So this becomes C2 equal to C2 plus 1, okay? So C2 equal to C2 plus 1, right? By just substituting AJ with its value 2. So this statement becomes C2 equal to C2 plus 1. So here we basically are going to go to C2 and add 1 to it. So here we just change it from 0 to 1. Is that correct?
Understood.
Okay. So yes, here we just finish one iteration of the for loop, and then we go back to the for loop again, and then we increase j by 1, so j becomes 2. So j is here, and then next we're going to execute this statement again, but aj has a different value. Now aj is 5, so this sentence becomes C5 equal to C5 plus 1. Right? So then we're going to go to find C5 and add a 1 to it. So it becomes 1. Okay, next. We're going to repeat the previous operation by increasing j by 1, and executing this sentence. Now aj has a new value, which is 3. So this is like C3 equal to C3 plus 1. So then we're going to increase C3 by 1. So C3 is here. Currently its value is 0. So we're going to increase it by 1. Okay. So so far we finished 3 iterations of the for loop. Can you guess? Can someone point out what are we doing in this for loop?
We're counting the amounts of each number there are?
Yes, we're counting the values. Great. We're counting values in A. The reason is this, okay? Let's just focus on this iteration, okay? At this iteration, we see a value 3 from array A, right? So then what we do is that we go to C3 and add 1 to it. So basically this is like, if you see a specific value, add the counter of that value by 1. Increase the counter of that value by 1. So that it becomes 1. Make sense?
Yeah, it makes sense.
Okay. And actually you can say so far we just go over 3 values in array A, 1, 2, 1, 5, and 1, 3. And then let's look at the counters of them. The counter of 2 is 1. The counter of 5 is also 1. And the counter of 3 is 1. So, but whereas 0, 1, 4, the counter of them is just 0 because we haven't seen any of those values. Okay. So and next, let's go through another go over another iteration by increasing j by 1. So j becomes 4. Now we see a 0. So aj is 0. So this sentence becomes C0 is equals to C0 plus 1. So we are going to add 1 to C0, and here it's going to be much more clear, right? So we see a 0. So we basically increase the counter of 0 by 1. This iteration, this for loop basically is like this. Whenever we see a value, we increase this counter by 1. And initially we set the counter of everything to be 0 because we haven't checked any values in array A. In this iteration, we set the counter of all values to 0 because we haven't seen any value in A yet. And now we are just start checking each value in A. And whenever we see a value, we just increase this counter by 1. So next, So now I'm going to skip writing j, but instead making it a little bit faster. So next we increase j by 1, so j goes to 5. We say aj is 2. So then we're going to increase the counter of 2 by 1, right?
Yeah.
Okay, so this goes from 1 to 2. And then next we see another value 3. So we're going to increase the counter of 3 by 1. So next we see 0. We're going to increase the counter of 0 by 1. So it's over here. And then we see a 3. So we're going to increase the counter of 3 by 1. So this becomes. So originally it was 2, right?
Yeah, it was 2. There are 3s right now.
Okay, so now it becomes 3. Okay, so and then we finish the second for loop. And at the end of the second for loop, this is the values in C that we get. So we got 2, 0, 2, 3, 0, 1. And let's check if this is really, if C is really the counter of the values in A. How many times do we see 0 in A?
Twice.
Yes, twice. So here we got to see 0 as 2. How many times do we see 1 in A?
0.
Yes, 0. And we see 2 twice. So that's why we have C2 as 2. We see 3 times. So that's why we have C3 as 3. Make sense?
Yeah.
Okay. And actually, this is the reason why we call this algorithm counting sorter, because we need to count the number of occurrences of each value. Okay. So next, let's check this the following iteration. Okay. So for I starting from 1 to k, for I starting from 1 to k, so here we know that k is 5. So we have ci equal to ci plus c minus 1, ci minus 1, okay? So let's be a little bit slow. So initially we have I as 1, and so this is like, if we translate this sentence into a simpler way, it's going to be something like this: c1 equal to c1 plus c0, right? Am I correct?
Yeah.
So here is like you are going to sum up these two values and put them as the new value of C1. So it's like you are adding adding C0 to C1. So now C1 becomes 2, right?
Yeah.
Okay. So then in the next iteration, okay, so we got this. We have I as 2. So then this sentence is going to be so we are going to substitute 1 with I with 2. So this is going to be C2 equal to C2 plus C1. Okay, C2 equal to C2 plus C1. So what does that mean? So we're going to add C1 to C2. Okay, so it's like we're going to add C1 to C2. Am I correct?
Yeah.
Okay, so this then C2 becomes 4. Guess what are we going to do in the next iteration?
Just add the next two.
Yes, we're going to add C2 to C3, and then C3 to C4, and C4 to C5. So basically, in each iteration, as here you can see that we basically use the previous value. We basically add the previous value to the value following that. Correct? Am I too fast?
No,
No,
you're good.
Okay, sure. So then next we're going to go another iteration by adding. So now I'm going to skip C4, so we're going to add C2 to C3. So C3 becomes 7. and then we're going to add C3 to C4, so C4 becomes 7. And then we're going to add C4 to C5, so C5 becomes 8. Okay? So then we finish this iteration because at this step, I equals to 5, which is the maximum value that it can be. So what are we doing here? What do these numbers stand for?
That's the count of the numbers.
Count of numbers? I don't think so, because so if you check over here, so 4, so here we have C4 as 7, but 4 only appears 0 time in the array A. So if this is the counter, then C4 should be 0, right?
Isn't it the sum of the amount of times each number, or not each number, but the numbers from the max or the minimum 0 to the max 5 appeared in your array?
No. Okay, so but so I'm going to explain what do these numbers represent. Okay, so let's say, for example, here we got C0 as 2. Okay, so in the array A, how many values are less than and equal to 0?
Two.
2, okay? And in the array, how many values are less than or equal to 1?
2.
2. In the array, how many values are less than or equal to 2?
4.
1, 2, 3, 4. Oh, sorry, 1, 2, 3, 4. So C2 equal 4. So basically, this number tells you how many for CI, for any value CI tells you the number of values that are less than or equal to I in the array A. Right?
Understood.
Okay. Okay, this is what we do over here. So it's basically going to count how many in the array A, how many values are less than or equal to a specific value. Okay, so this is what we do. Any question?
Nope.
Okay, so next let's look at this. Okay, so we got a for loop, and instead the for loop, what we do is like BCAJ equal to AJ. So what I mean, this seems really complicated, right? We have array of array references, and then we have some value assignment. But to make it a little bit clearer, so let me put it in this way. Okay, suppose, okay, so suppose here my objective is to sort the students in a class from the shortest to the highest based on the height. So let's say if we got a student whose height is this 5 feet and 6 inches. Okay, so so let's say we got Alice whose height is like this, and so if I tell Alice that inside the classroom, in the classroom, okay, including Alice himself, there are 8 students whose height is less than or equal to Alice's height. Okay, again, Alice's height is 5'6", and then in a whole classroom, there, including Alice, there are 8 students whose height is less than or equal to 5'6". Okay, so if I put Alice in the 8th place of our classroom, am I correct?
Yes.
Yes or no?
Yes.
Yes. Okay. So basically, here we can say this: the number of values that are less than or equal to or this. Let's go over here. Okay. So 8 is basically the rank. This is basically the rank of Alice in the classroom. Okay. So if Alice ranks the 8th shortest in the classroom, then it's pretty safe for us to put Alice in the 8th place. Right?
Yes.
Okay. So so then if you understand this, it's going to be a little bit easier for us to understand this. Okay. So so first, let's say for j starting from 1 to the length of the array. So the length of the array A is 8. So here the initial value of j is basically 1. So here let's say BCAJ equal to AJ. So what is AJ now?
2.
2. Okay, so here we see a value 2. Okay, and B. So here if we substitute AJ with 2, what we can do is that BC2 equal to 2, right? So this is what the result after we translate this statement in a more simple way. Okay, in a simple way, we have BC2 equal to 2. Okay, so here, what is C2? It's 4, right?
Yeah.
Basically, C2 is what? C2 is the rank of I. So the rank of 2 is 4. Okay, so after we see a value 2, we go to the array C, the corresponding place of the array C to find its rank. Okay, so here we say that so 2 ranks in the 4th place among all the values in the array, right?
Yep.
Or in other words, there are 4 values that are less than or equal to 4.
Yes.
Okay, so here we find, okay, so this is 4, so this becomes B4 equal to 2. Okay, so basically what we do is that we go to the array C to find the rank of 2, which is 4, and put 2 in the corresponding place of B. So we are going to assign 2 to B4. Right?
Okay.
Yes, this is pretty much like if we know the rank of Alice is 8, we're just going to put Alice in the 8th place of the classroom.
Gotcha.
Okay, so and then any question? This is really important. So any question? If you have question, just ask it now.
Yes, I have one question.
Sure.
So what if there's a negative number on that array list?
Okay, so there cannot be negative number in the array, because in order for us to apply counting sort, the array must be integers from 0 to k. So if you got an array with negative values, you shouldn't consider counting sort.
Oh, okay. So I have to use like other sorts to deal with the negative number.
Yes.
All right. Okay, gotcha.
Any other question? Okay, so here you can see the steps is that, okay, first we go to array A, find the value, see a value, and then we go to array C to find the rank of that value. And then, so the rank is going to be pretty much the position of the value in B. So we are going to put the value in the corresponding place of the array B. So it's like So whenever we see a value, we go to array, the corresponding place of the array C to find its rank and put it in that place of array B. So this is the procedure for us to put this 4 in it. Okay. Okay. So next, next we're going to execute this statement. We are going to do CAJ minus minus. So here AJ is 2. Okay, we're going to do C2 minus minus. We're going to decrease C2 by 1. We're going to decrease C2 by 1. And the reason for us to do that is that, okay, so now this number is gone. It's like we just put this number in the correct place. And among all the remaining numbers, the rank of 2 is going to reduce by 1. So it becomes 3. Among the remaining numbers, only three values are less than or equal to 2, because a number 2 has already been arranged to the correct place. So the rank of 2 just decreased by 1. Make sense?
Can you say that one more time?
Yeah, no.
Okay.
That was a little bit strange.
So, okay. So here, what we can see is that previously we have C2 as 4, and the reason is that among all the 8 values, there are 4 that are less than or equal to 2, right?
Yeah.
Okay. And now we just move the value 2 from array A to array B. So it's like this value is gone. And so among all the remaining 7 numbers, how many values are less than or equal to 2?
3.
3. So that's why we just decrease C2 by 1, because one instance of 2 is already removed. Make sense?
Yeah. I get it. Okay. Thank you.
No problem. So that's why we do this. Okay. So and here you can see that in every iteration, we basically do 2 steps. We're going to execute these 2 steps. In the first step, whenever we see a value in array A, we go to the corresponding cell of array C to find its rank, and put the value in the corresponding rank of array B. And then we go back to the array C and decrease its rank by 1. Simple?
So at the end of, like, when you use every number, the C array is going to go back to all zeros?
No, it's not going to be all zeros. So it will be clear later, okay?
Okay.
Sure. Okay, so next, we're going to increase J by 1. So for now, I'm not going to write down the values. So write down the index of J. So here, when J is 2, we see a value 5. So where should we go to find the index of or the rank of 5? Where should we go to find the rank of this value? 5.
Go to C.
Say it again.
You go to the array C and then find 5.
Yes, we go to C5. Yes, find, okay, the rank of 5 is 8. So then we go to the 8th place of the array B, and then put the value 5 in it. Okay, and then in the second step, we're going to decrease the rank of 5 by 1. So it has a value 7. Okay, make sense?
Yeah.
Okay, and then in the next iteration, we see a value 3. We're going to see 3 to find its rank. It is 7. Okay, so then we're going to assign this value to B7. So this value becomes, so this place is going to be 3. And then we're going to decrease the rank of 3 by 1. So it becomes 6. And next we see a 0 in array B. So array A. So we're going to go to C0 and find its rank. It is 2. So we're going to assign 0 to C2. And then we're going to decrease its rank by 1. And next, we see a 2 in array A. So we're going to go to C2 to find its rank. Now we see that its rank is 3. So we're going to assign is 2 to B3. Okay, next and so sorry, I forgot to decrease its rank. So then we're going to decrease the rank by 1, so it becomes 2. And next we're going to go to we see a value 3, so we're going to C3 to find its rank. It's 6, so we're going to put it in the 6th place of the array B. So and then we're going to decrease its rank by 1. It becomes 5. Okay, so next we see 0, so we are going to see 0 to find its rank. It's 1, so we're going to put it at 1 in array B, so it's going to be 0. And next we see the value 3, so we're going to see C3 to find its rank, which is 5. So 3 should go over here, and then we finish the last iteration. The last for loop, and then we basically finish the whole algorithm. So, and at the end, you can see that, so please check, does B include the same set of numbers as A?
Yeah, I see.
Yeah.
And are all the values in B sorted?
Yeah.
Okay, so yes, then, so here we are assured that the algorithm works by sorting the array correctly. And so next, to answer your question, okay, what does, sorry, here, I think I forgot to decrease the counter of 0 once, okay? So here, to answer your question, so at the end of the algorithm, so C does not become all zeros, right? So now what does C represent? What does C represent?
The rank -1.
Not -1. See, here we see C0 as 0. We see C1 as 2. So here, let's say Ci basically measures the number of values that are less than I. So how many in the array A, how many values are less than 0?
0.
0. How many values are less than 1 in the array A?
2.
2. How many values are less than 2?
2? Yeah.
2. Yes, 2. Sorry, I forgot to decrease the counter of 3 once. Okay, but in the last iteration, I didn't decrease its counter. Okay, so how many values are less than 3 in array A?
4.
Yes. So at the end of the algorithm, C becomes this. Ci is the number of values that are less than I, not less than or equal to. Make sense?
Yeah, that makes sense.
Okay. So
Yeah, makes sense.
yes. Okay. And then cool. So this is the algorithm. And so do you have any question regarding how this algorithm works?
Yeah, I had a question.
Sure.
For the arrays, like for A and B, how come we start the index with 1?
Okay, so because here, okay, basically your question is that why array A and B start with index 1, but C starts with index 0. Okay, so this is a very good question. So as I said before, by convention, our textbook so uses the index starts from 0, but here for array C, to use index starting from by convention, the array show starts with index 1. But array C is an exception. It starts with 0. The reason is that C is the counter of the values in the array A, and then in the array A, the minimum value is just 0. So it uses 0 for convenience. And actually, to be accurate, it should be the array C. If we really want to be accurate, the array C should be should use index start from 1 to k plus 1, and then the counter, say if we want to find, okay, how many values how many values are, so Ci basically is the counter or the rank of value I minus 1. So it's like all these indexes should be increased by 1, but the numbers inside them just keep unchanged. And for the sake of simplicity, the textbook just assumes that the index starts from 0. And because if we use the index starts from 0, we can easily relate it to the counter of the index. Okay. Am I clear?
Kind of, because like if I were to write this program, wouldn't my like the compiler wouldn't assume like?
Okay, so for you to do your homework, you should also follow the same convention. Okay, you just use C. You just say in the array C, you just assume that the index starts from 0, because C basically C0 represents the counter of 0. But instead, for you just need to when you play with the array A and B, you just need to be careful. You just need to change the starting and ending index for the array A. Okay, just use start for here. You need to say the array index start from 0 to length minus 1, and then here another change is that, so for example, the counter, if the counter if C0 is 2, it means that C0, so the counter of 0 is 2, right? So we should use this. We should add a minus 1 over here, because this tells you that 0 should go to the second place of array B. But the index of the second place of array B in Java should be 1 instead of 2. So you should have a minus 1 over here. That's the only 2 changes that you need to make.
Okay, and we have to, okay, that makes sense. Thank you.
No problem. Any other question? Okay, so if now I want to talk a little bit about the complexity inference. So teach you how to do it by yourself, even though this is kind of like not required for this class. So when we are inferring the complexity of an algorithm, of a piece of pseudocode, there are only 2 parts that we need to pay attention to. The first part is the loops. So basically, we are interested in how many loops are there in how many iterations are there in a loop, and the other one is the function call. Okay, the other one is the function call, because if your function calls another function, you need to take the complexity of that. If function A takes function B, calls function B, then we need to take the complexity of function B into consideration. So, but here in this algorithm, because we are playing with sorting, so we only have loops. We don't have any say other function calls. So we just need to focus on these for loops and check how many iterations are there in each loop. Okay, so how many iterations are here in the first for loop?
Is it 5?
Sorry?
5?
To be general, it is k plus 1.
Oh, okay.
Right? So because the index starts from 0 and ends at k, so it's k plus 1 iterations. And then how many iterations in the second for loop? The length of the array A, right? Because the loops start from 1 to the length of the array length. So we can use n to represent the length of the array. So here we got n iterations in the second for loop. How many iterations are there in the third for loop?
Would it be k minus 1 since you're starting at 1?
K. So it's k, not k minus 1, because it starts from 1 and ends at k. Like if we let's say if this is the example that we discussed before. Let's say if we're talking about number of days in February, we know that February starts with 1 and ends at February 28th. So how many days are there in February?
28.
Yes, 28. So same here. If it starts at 1 and ends at k, then the number of iterations is just the k. Okay. So so here is the last one. Okay. So for j starting from 1 to the length of the array A, how many iterations?
Eight.
Or to be general, n iterations, right? We just need to substitute 8 with the length of the array. Correct? So this is n. And here, the thing is that because all of this, so these for loops, they are parallel, there is no nested for loops. So if there is no nested for loop, there is no nested loops, we just need to sum up the number of iterations. So if we sum them up, it will be 2k plus 2n plus 1, right? And when we are talking about complexity, so we want to avoid the constant, because the constant remains constant. They don't grow. They don't. So with respect to k and n, because when k and n reaches very big, this 2 and 1, they are just negligible. So we can totally ignore them. So that's why we got the total complexity as k plus n. Where k is the maximum value in the array A, and n is the length of the array. Okay, so you don't have to understand these detailed steps, but it's good to know. So if you go to your graduate school, you will need to understand these steps. Okay, so yes, then so here the counting sort complexity is n plus k. So this is what we discussed. So far we learned so except for heap sort, we learned 4 sorting algorithms: insertion, merge, quick, and counting sort. So in practice, if you go to a job interview, you should always go for quick sort, because it's the best one in practice most of the time. Okay.
So like, what would be an example of like a problem they would give us like on an interview, like that we have to use like quick sort on?
Sorry.
So like, what kind of like problem would they give us like to use quick sort in like an interview?
So to be honest, in your job interviews, the opportunity for you to be asked to implement a sorting algorithm is very low, because people take it as standard. So because say if you use Java already provides the sorting function. So when you are doing a coding project, there is no need for you to implement a sorting algorithm by yourself. But here we start our course with sorting algorithms because they're relatively easier for us to understand. So and also it's good to know the design of this algorithm. So I mean when you are say in the future, when you are discussing the project with your colleagues, you know these things. Okay. Any other question? No? Okay. So then after this one, you will have your homework 3. So in your homework 3, you are here I'm going to terminate the presentation from iPad and then go to my laptop. So in your homework 3, so here I'm going to pull up the files. So this is your homework 3, and so in your homework 3 you have 4 tasks, but the last one is just optional. So the first task is to implement quicksort, and then the second one is to implement counting sort, and the third one is like to generate a report, and I think that your pretty familiar with this. And then the last task is to implement heap sort. And if you do that, you can get 100 extra credit. So to help you start with the extra credit, I give you a separate file named sort4. So so then if you want to go for this extra credit opportunity, so you need to use this. You need to use this file. So if you just want to focus on the first 3 tasks, use this file, sort3.java. Okay. So any question?
Nope.
No? Okay, so I mean, how's your homework too? It's going to you will need to submit it at the end of today. So how's that?
It was good.
Okay, cool. So anyone finish that? So just type in 1 if you finish that in the chat area. I'm still working on it. Okay. Okay, so I see at least 3 people have already finished that. How long did it take? Finish. Almost done. Cool. Cool. 7. I think at least 7 or 8 students have finished that. 8 hours. I was stuck. Yes, that's what that's pretty normal. I mean, well, in 2 hours, you're pretty fast. So cool. I mean, 8 hours is I mean, it's the median time based on my experience. 6, yes, cool. Still pretty good. Okay. So this means that for those of you who have not started this homework yet, yes, you probably will need to rush to your lunch and then just spend the rest of your day on it. So it's okay. And yes, if you are stuck at something for maybe 2 or 3 hours and you cannot figure it out, feel free to send your code to me. I will help you. Okay. So then, yes, if no other question, that's the end of our class for today. So have a good weekend.
Have a good weekend.
Thank you.
Good weekend, Professor.
All right, have a good weekend.
Have a good weekend, sir. Thank you.
Have a good
you.
weekend.